Okay, so today is going to be a shorter video. We're just going to review asymptotes and then look at holes in the graph and talk a little more in depth about holes in the graph. So if you remember last lesson, we talked about the difference between an asymptote and a hole in the graph. So an asymptote, a vertical asymptote, those factors will still be on the denominator. A hole in the graph, you'll have a factor on the denominator, but it ends up canceling out. Okay. All right, so let's look at these two examples here and try to figure out if the graphs have vertical asymptotes or holes in the graph. So the first rational expression, hopefully you will notice that 9 minus x squared, that is a difference of squares. So it's the same as 3 minus x times 3 plus x. Nothing ends up canceling out here, so that means both of these factors will end up giving me vertical asymptotes. So I will have a vertical asymptote when x equals 3 and when x equals negative 3. Okay, and actually while we're looking at it, let's look at the horizontal asymptote too. So this will have a horizontal asymptote. If you remember our rules, and I'm just going to write them out at the top here again. So if the degree of the numerator is higher than the degree of the denominator, like this, for example, like if we had x over 1, there's no horizontal asymptote. If the degree of the denominator is higher, such as 1 over x, we have a horizontal asymptote where y equals 0. And if the degree of the numerator and denominator is the same, and I'm kind of running out of room here, so let's write it on the bottom. So degree the same, degree the same. That's when we divide the leading coefficient. So for example, 2x over x would give me a horizontal asymptote at y equals 2. So I probably didn't write that very neatly, but hopefully that helps you remember. So in this case, when we're looking at our rational expression before we ended up factoring it, we notice that the degree of the numerator and the denominator is the same, which means we would divide the leading coefficients. So 1 over negative 1 would give me negative 1. So this graph would have a horizontal asymptote when y equals negative 1. All right, let's look at our next example here. So I'm going to start off by factoring. So I know that I'm looking for two numbers that multiply to give me negative 2 and add to give me negative 1. So those two numbers are going to be x minus 2 times x plus 1 all over x plus 1. All right, so in this case, my x plus 1's cancel, which means now I do not have a vertical asymptote. I have a hole in the graph, also known as a point of discontinuity. So yesterday when we looked at graphs, okay, we would notice that a hole in the graph is actually a point on the graph. So for example, let's say this is my graph. It's an actual point on the graph. So if we wanted to figure out that point, okay, it's going to have an x value, but because it's a point on the graph, like any other point on the graph, it also has a y value. So in this case, I can find my x value pretty simply by just figuring out the 0 of that factor that I canceled out. So I know that this is going to have a point of discontinuity at x equals negative 1. To figure out the y value though, all I'm going to do is I'm going to take that negative 1 and substitute it back into the equation of whatever I have left over after I canceled those terms out. So negative 1 minus 2 is negative 3. So the hole in the graph would be at -1, -3. Okay, and I'm going to actually go back and graph this on my graphing calculator as well. So let's type it in there. X squared minus x minus 2 bracket divided by bracket x plus 1. Again, make sure you're putting the numerator in brackets as well as the denominator in brackets. And then we'll go to graph, and you'll see, hey, wait a second, that looks like a linear graph. There is no asymptotes, but you can actually notice, okay, the hole in the graph on your table of values. So I'm going to scroll down here to where I get x equals -1. And also, you can kind of take a guess of what you think the y value would be. So we ended up with a y value of -3, which makes sense because that kind of looks like the y value that would be missing on this table of values. All right, let's go back to our notes here. So these were some of the questions you worked on yesterday. Hopefully you liked the pretty balloon house here that I found. And we're actually going to just keep looking at holes in the graph and vertical and horizontal asymptotes with these next examples. So we always need to start by factoring. So x squared plus 5x plus 4. I'm looking for two numbers that multiply to give me +4 and add to give me +5. So in this case, those two numbers are going to be x plus 4 times x plus 1. All over x plus 4. The x plus 4s will cancel out, so I know I have a point of discontinuity. So I'm going to call it PD, point of discontinuity. So the x value of that point of discontinuity is just the 0 of the factors that you canceled out, so it's going to be -4. The y value of that point of discontinuity you can find by substituting that -4 in. So -4 plus 1 gives me -3. So then my point of discontinuity would be when x is -4, y is -3. All right, let's try our next example here. So I'm looking for two numbers that multiply to give me +3 and add to give me -4. Those two numbers will be x minus 3 times x minus 1 all over x minus 3. The x minus 3's cancel out, so that means my point of discontinuity would be when x is 3. And again, to find that y value, you just substitute the 3 into whatever's left in your equation. So I have an x minus 1 left over after I canceled those common factors. 3 minus 1 gives me 2. So my point of discontinuity would be when x is 3, y is 2. All right, this next example, it might seem tempting, but you can't actually factor x squared plus 5. So that means there are no common factors for me to cancel out. So there are no points of discontinuity. But I do have a vertical asymptote because I have x minus 1 on the denominator. So that means my vertical asymptote would be x equals 1. All right, and I have my last example on this page. So y equals x squared minus x minus 6. So I'm looking for two numbers that multiply to give me -6 and add to give me -1. So those will be x minus 3, x plus 2, all over x plus 1. So I know that there will be a vertical asymptote here. There will not be a point of discontinuity because there are no factors that cancel out. So my vertical asymptote would be x equals -1. Okay, and let's actually backtrack and just see if there's any horizontal asymptotes with these examples. So here in my first one, the degree of actually all of them, okay, all 4 of these examples, the degree of the numerator is higher than the degree of the denominator. So if you look back at our last slide or what we talked about earlier, you would know that there are no horizontal asymptotes for any of these 4 examples. Okay, before I leave you today, I do want to go over just a couple more examples here. All right, so do you think that you could end up with a vertical asymptote and a point of discontinuity? And I'm going to write this in factored form for you, so it'll be super easy. Yes, you could. So in this example here, if you look at it, notice how my x plus 1s would cancel out. Okay, so that would be my point of discontinuity. So my point of discontinuity would be when x is -1. To find the y value, I'd have to substitute that -1 back into whatever's left over. So I would actually have to take -1 minus 2 all over -1 minus 5, and then I would need to type that in my calculator, which would give me ½ So that would be my point of discontinuity. But I also have a vertical asymptote in this example because I have a factor that did not cancel out. So my vertical asymptote in this case would be x equals 5. This example would also have a horizontal asymptote because if you were to expand these 2 binomials out, and I can even expand them out to show you, you'd end up with x squared plus 1x minus 2x, which gives me -1x minus 2 all over x squared minus 5x plus 1x. That would give me a -4x minus 5. Okay, so in this case, the degree of the numerator is the same as the degree of the denominator, so I would divide those leading coefficients. 1 divided by 1 gives me 1, so my horizontal asymptote would be at y equals 1. So that's it for points of discontinuity. Try some questions, and I'll probably give you a couple more that you can work on as well, or you can finish the ones from yesterday in your notes.